Quality control is the backbone of manufacturing, ensuring that products meet the desired standards and expectations. In this pursuit, the Acceptable Quality Level (AQL) chart emerges as a vital tool, guiding manufacturers in assessing and maintaining product quality. This comprehensive guide delves into the intricacies of AQL charts, shedding light on their significance, components, and real-world applications. What is AQL? Acceptable Quality Level (AQL) is a statistical tool used in quality control to determine the maximum acceptable number of defects in a given sample size. It sets a threshold that demarcates acceptable and unacceptable quality levels, aiding manufacturers in making informed decisions about product acceptance or rejection. AQL charts play a pivotal role in streamlining quality control processes, ensuring that products reaching consumers meet predefined quality standards. By providing a systematic approach to inspecting samples, manufacturers can minimize the risk of defective products entering the market. Components of AQL charts. The components of AQL charts include lot size, defining the total units, sample size, determining the subset for inspection, and acceptance/rejection numbers, setting criteria based on statistical tables for quality assessment. Here are the components of AQL, Acceptable Quality Level, charts in tabular format. Component Description. AQL Acceptable Quality Level, the maximum percentage or number of defects considered acceptable. Sampling Plan. A predetermined plan specifying the sample size and acceptance criteria for a given lot size. Lot size. The total quantity of products or items in a batch or lot being inspected. Sample size. The number of units randomly selected from the lot for inspection. Acceptance number, C. The maximum number of defects or defective units allowed for the lot to be accepted. Rejection number, R. The minimum number of defects or defective units that, if exceeded, will lead to lot rejection. Producer's risk, alpha. The probability of rejecting a good lot, type 1 error, when the lot's actual quality is acceptable. Consumer's risk, beta. The probability of accepting a bad lot, type 2 error, when the lot's actual quality is poor. Critical, major, minor defects. Different levels of defects categorized by their impact on product quality. Single sampling plan. A sampling plan where only one sample is drawn and inspected. Double sampling plan. A sampling plan where two samples may be required for inspection. Acceptance Quality Limit, AQL. The quality level that is the worst tolerable process average when a continuing series of lots is submitted for acceptance sampling. The lot size is the total number of units in a production run. AQL charts are customized based on the lot size, acknowledging that larger production runs may have a higher likelihood of defects. Determining the sample size is a critical aspect of AQL chart. It involves selecting a subset of the total lot for inspection. The sample size is influenced by factors such as the lot size, desired confidence level, and acceptable quality level. Acceptance and rejection numbers in the AQL chart define the limits within which the inspected sample is considered acceptable or unacceptable. These numbers are derived from statistical tables, ensuring a data-driven approach to quality control. Commonly used AQL levels. AQL levels are typically expressed as a combination of a code letter and a corresponding number. The code letter represents the sampling plan, and the number represents the acceptable quality level. Here are some commonly used AQL levels. Code letter. AQL level, %. Description. I. 0.065. Strictest, suitable for critical applications. 2. 0.25. High level of inspection, suitable for important products. 3. 1.0. General inspection level, commonly used in regular cases. 4. 2.5. Lower level of inspection, for less critical situations. V. 4.0. Relaxed level, suitable for less critical items. S1. 0.1. Special level for critical applications. S2. 0.25. Special level for high-quality products. S3. 0.4. Special level for regular cases. Note, the AQL level represents the percentage of defects or nonconformities that are considered acceptable during the inspection process. Lower AQL levels indicate stricter quality standards and require more rigorous inspection. It's important to note that the specific AQL levels used may vary depending on the industry, product type, and individual company standards. Always refer to the relevant quality control documentation and standards applicable to your specific situation. Types of Acceptable Quality Level, AQL, chart. Acceptable Quality Level, AQL, charts are commonly used in quality control to define the acceptable level of defects or nonconformities in a batch of products. AQL charts help manufacturers and inspectors make decisions about accepting or rejecting a batch based on the observed level of defects. There are different types of AQL charts, and two common ones are the single sampling plan and the double sampling plan. Single sampling plan. Zero acceptance number, C equals 0 in this plan, the inspector accepts the entire lot if 0 defects are found in the sample. Otherwise, the lot is rejected. Fixed acceptance number, C this plan involves specifying a fixed number of defects that are acceptable in the sample. If the number of defects found is equal to or below this specified number, the lot is accepted, otherwise, it is rejected. Random sampling. In this approach, samples are randomly selected from the lot, and the decision to accept or reject is based on the number of defects found in the sample. Double sampling plan. Double sampling, C1, C2 this plan involves two stages of sampling. If the first sample is accepted, the inspection is concluded. If the first sample is rejected, a second sample is taken. The decision to accept or reject is then based on the results of the second sample. Sequential sampling. Similar to double sampling, sequential sampling involves an ongoing evaluation of the lot. Samples are taken one at a time, and the decision to accept or reject is made after each sample. This continues until a decision is reached or a predetermined number of samples is reached. Multiple sampling plan. General inspection level 1, 2, 3 AQL charts often include different inspection levels 1, 2, 3, based on the criticality of the product or the level of scrutiny required. Higher inspection levels involve larger sample sizes and more stringent acceptance criteria. Special inspection levels S1, S2, S3 special inspection levels are used when the inspection needs to be more stringent than the general inspection levels. Skip lot sampling plan. AQL for lots not inspected. In skip lot sampling, certain lots may not be inspected. Instead, a decision is made based on the history of the supplier's quality performance. These are just a few examples, and AQL charts can be customized based on the specific requirements of the industry and the product being inspected. The choice of the AQL plan depends on factors such as the desired level of confidence, the acceptable risk of accepting a defective lot, and the cost and time constraints of the inspection process. Acceptable quality level, AQL, charts FAQs. Here are some frequently asked questions, FAQs, about AQL charts. What is acceptable quality level, AQL? AQL is a statistical measurement used in quality control. It represents the maximum percentage of defective units or the maximum number of defects that are considered acceptable in a particular sample from a batch of products. How is AQL determined? AQL is typically determined based on the quality standards and requirements of a specific industry or product. It is agreed upon by the manufacturer and the customer, often through negotiation. What is an AQL chart? An AQL chart is a graphical representation that shows the relationship between the sample size, acceptable quality level, and the corresponding acceptance and rejection points. It helps in determining whether a batch of products meets the specified quality standards. How do I read an AQL chart? A typical AQL chart consists of rows and columns. The rows represent different sample sizes, and the columns represent different acceptable quality levels. The intersection of a specific sample size and AQL level provides the acceptance and rejection points, indicating the maximum allowable defects. What are the acceptance and rejection points in an AQL chart? The acceptance point is the maximum number of defects allowed in the sample for the batch to be accepted, while the rejection point is the minimum number of defects that will result in the rejection of the entire batch. How is AQL applied in real-world manufacturing? In manufacturing, AQL is applied by inspecting a random sample of products from a batch. If the number of defects in the sample is below the acceptance point, the entire batch is accepted, otherwise, it may be rejected or subject to further inspection. Can AQL be adjusted based on product importance or criticality? Yes, AQL levels can be adjusted based on the criticality of the product or its impact on end users. More critical products may have lower AQL levels to ensure higher quality standards. What are the limitations of AQL? AQL is a sampling method, and it does not guarantee 100% quality. There is always a risk of accepting a batch with defects or rejecting a batch that is actually acceptable. It is a statistical approach that balances the cost of inspection with the level of quality assurance. In conclusion, acceptable quality level, AQL, charts stand tall as pillars of quality assurance. From defining AQL levels to navigating lot sizes and conducting inspections, AQL charts guide manufacturers toward a horizon of excellence in every production run. Embrace the power of AQL charts, integrate them into your quality control processes, and elevate your products to meet and exceed customer expectations.